All right, so last couple days I haven't been here. Declan, please reach out if and when you watch this video, and I will make sure that we're squared away. But we had the quadratic formula. Here it is. What's the discriminant?
The radicand, or the stuff under the discriminant.
Cool. Which very specifically, what is it?
A number.
And you're still right, but b squared
Minus
4ac. Now, when we deal with the discriminant, all this is it's a good look ahead before we complete a problem to know what kind of answers are we expecting. It's helpful to know if there's one or two or none or whatever the case might be. So as we look at this, we saw three possibilities. If this is positive, and that's just a plus sign, then you get two real x-intercepts. Okay, now we could call them roots. X-intercepts I think works nicer. Okay, or roots, and I'll just write both of them just in case. Okay, what if it's exactly 0? One real root. Now, there's really two that just happen to be the same number. And we'll look into that because that's a weird thing to say the first time. What if it's negative? Two invisible, imaginary, non-real roots. Are we ever going to get to see a graph with these roots cross the x-axis?
Why would it be one not dimension?
What's up? So that's a harder question because one of them is plus I something and one of them is minus. There's why we have two. Okay. Now, this was essentially all of 2.6, right?
Yeah.
Okay. Yesterday in class, theoretically, you guys started 2.7.
Yeah.
And 2.7, I think, was linear quadratic.
Non-linear systems.
Is nonlinear systems?
Yeah.
Okay, so don't change yours. And there was confusion, you might have heard me talking about it. If you need to step out, I'm okay with it, just for the record. If it's something on my face or something, please tell me. Okay, so I'm right linear quadratic right now. You guys wrote nonlinear. They're the same thing. This one just says I have one linear function and one quadratic. Now, just like we saw with the possibilities for drawing our quadratics, if I have a parabola and a line, there's only three possibilities. How can they meet? And do we have pictures in our notes? Yeah, how many times could they intersect? 1, 2, or 0. And I'm going to pause here for just a brief second. The example that we worked yesterday, and I don't have it up here right now, but it was ugly. And as we go through this, there's one more y value that you guys don't have. I'm going to suggest we'll come back to that here in just a minute. We'll make sure we get the calculator number. Let's do a couple more systems. Okay, so we are in an example of solving these systems. And again, Declan, if you're watching this, 2.7 from first hour, 10:27. I'll post it, I'll update the title and stuff. But we're on example C, is that true?
Yes.
Okay, so we're going to do two things, because you're going to see a problem on the assignment tonight that asks you to go just a little tiny step further, and let's just look at one more here. So on C, I want us to solve the following system of equations. Let's say our first one is y equals, I don't know, x squared plus, we'll say 2x minus 1. And let's say our other equation is y equals x plus 2. Now, to solve this system of equations, we have a few, right, I don't have my walkable one on. We have a few different options. Theoretically, we could conceivably eliminate these and make it work, but more naturally, rather than doing that, is either of these equations solved for the other? And by that I mean, is either equation easy to solve or already solved for a single variable? So which one's easy to solve, and for x or for y? And follow-up, is it already solved? Now, when I say solved, just to be very clear, I'm not looking for a number. All I mean is, do I have y equals something? Okay. Well, gosh, these both have y's, right? Instead of writing this y, here's another way to write it. We all agree with that. And this seems like review stuff from yesterday, right? Okay. So, what am I going to write in my next line? Like, we're actually just going to jump in and do it. Yeah, I'm going to plug x plus 2 in for this, and we'll obtain x plus 2 equals x squared plus 2x minus 1. And this step right here, from this to this, we just substitute. That's all we've done. We're using substitution, and we've done it. Okay. All of a sudden, once we've done this very initial step, the rest of the problem is pretty much what we've been doing. What do I always want to set a quadratic equation equal to if I'm looking for solutions? Every single time. Do I set it equal to 1 always? 2, 3?
1?
I don't think it's 1 either.
0?
It's 0. Nice work. Okay, I want a 0 on this side. How do I make that happen? I mean, I'd probably keep the positive x squared. I can minus 2, I'm cool with that. And I'm going to do 2 steps in 1. If I do this, I still have an x over here. Minus 1. If you say x on the end, I'm okay with it. Now, when I'm doing these, and I'm doing 2 steps in 1, but I want to be very clear about how I'm writing it, and I'm doing it intentionally. Notice, when I take 2 away from each side of the equal sign, I write the minus 2 underneath the other number. And the x's, I write underneath the x, so I don't get goofed up trying to combine it with the x squared. Okay, by doing this, on the left side of this equation then, I believe I'm at 0 equals x squared plus how many x? So we had 2 and we subtracted 1, so it's just 1. And what's negative 1 minus 2?
But isn't 2x? You remove 1 and 3?
So I just subtracted x. What's 2x minus x?
2 minus
Oh, 1.
Mm-hmm. And that's all we're doing. And this last number? Negative 3. Okay, at this point, I cannot, and I will just keep repeating this over and over, don't jump to quadratic formula immediately. If it winds up being quadratic formula, that's fine and dandy, but we're not going to jump there right now. Okay, let's run through. What's the first thing I always check with factoring? There's not one. It's not a binomial. Do you know the square root of x squared?
1.
Give me a better answer.
X.
X? Do you know the square root of 3?
Yes,
So if you say yes, I'm going to immediately say, what is it? So no is the appropriate answer. Like it's possible, right? And I'm just trying to make sure that we get that distinction in our head. It's not a nice square root. Okay, bummer. What's the leading coefficient though?
1.
Okay, so what might work? Why would I care about the leading coefficient of 1?
So you do a short.
So I can try a shortcut. So here we go, let's try. I need to find factors of negative 3 that add up to 1. It's not 1 and negative 3, and it's not 3 and negative 1. I can't do it. Right? Like, it's just impossible. Okay, at this point, we have gone through all of our factoring list, and none of our other methods work to solve this. Which means we're going to default to what, Kian? We're going to use the quadratic formula. Now, let's do so. Gosh, it's so embarrassing, but here I am. I've completely forgotten that.
Minus.
Is it B?
Plus or minus the square root.
You're right, but let's back up. It's not B, I don't think.
No, it is B.
Is it just B?
Minus B.
Okay, did you say minus?
Yeah.
I'm sorry, I did not hear you. So negative B is our first term. Now, looking at this, it's never required, but what's A and B and C?
X and
A is
So don't call it X. Only the numbers in front of them can.
1.
1. B? Are you sure? Are we solving this equation or are we solving this equation? We're solving this one. It's a 1. What's C?
Negative 3.
Okay, we have A, B, and C. Let's use those values from here. Once it's equal to 0, we're good to roll. So here we go. X equals negative B, so that would just be negative 1. Plus or minus. Now, if I skip too much, just let me know. I'm going to plug in 1 squared here, right?
Yes.
What's 1 squared? Minus 4 times 1 times negative 3. And all of this gets divided by 2a, which is 1. Lucy.
Question. So because if you're multiplying by 1, like putting parentheses 1, do you really need to put the 1 there because it's not gonna like change?
So you do need to put the 1, but you don't really have to put the parentheses and square it. Because what's 1 squared?
1.
So we definitely need the 1, but if you, like on the first one, I didn't do it. I just squared it in my head because it's going to be the same, right? Yep, I agree with you.
So what about the bottom? Like,
Same thing. You don't really need this as long as you know it's 2.
okay.
And I'm just trying to make sure that all that stuff is showing. But absolutely, you might skip this little spot. Okay, so if you didn't skip it, that's okay. We now have -1 plus or minus, and let's work out what's going on in here. This is 1 minus, what's 4 times 1? Times -3. So notice, this becomes 1 minus -12. And if you're going to run into problems with the quadratic formula, this is where it's going to happen. If you are a calculator typer, something happens here. All divided by what? 2. And what does, is it me?
No.
Okay.
I'm sorry, I'm so sorry.
You're okay.
I'm so rude right now. I'm sorry.
What happened to you?
Literally, I went to tell her something, and I went like this, and then I stopped, and then it just got like funny for some reason. Like, it's not you. This
Okay.
happens so sometimes. And
Well, I'm funny, but
no, you are funny.
fair.
No, you
All
are.
right.
Like laughing at me.
No, you're good. Okay. I'm trying to draw our attention to this because this is the spot where we lose attention. Not attention. I'm losing attention. This gets people goofed up. What happens? They add. This becomes -1 plus or minus the square root of what number? -1 plus or minus the square root of 13?
Yeah.
All over 2. Now, here's the deal. I'm not a huge fan of the super ugly decimal approximate answers. For everything apart from graphing, this is where I would stop. I would not go any further than this. Not at all. Okay, with that in mind, I'm going to graph this on Desmos, but I'm going to make you guys help me without a calculator. Let's approximate what this is. Nobody knows the square root of 13. That's okay. Do you know which 2 square numbers it's between?
There's
So you say there isn't, but there's definitely a square number smaller than 13, and there's a square number bigger. What's the first square number, or the first number smaller than this that's nice to take a square root of? So 4 squared is 16, right?
Yeah.
So 16 is on the higher end. 3 squared is 9. So do we agree that this is between 16 and 9? Which means I know for a fact that my square root is between 3 and 4. Okay, so right now this is not correct. I'm going to pretend like it's 3.5, just approximately. So check it out. If I want to just confirm my answers, and if we were getting like really precise graphs, we would actually find those. But if I think this as approximately, without grabbing a calculator, -1 plus or minus 3.5 over 2, we can see whether or not this agrees with the graph that we're about to view. Now, really approximate here. I didn't touch my calculator once. Okay, what's -1 minus 3.5?
3.4.
Negative
Oh, wait, no.
4.5.
I think -4.5, if we do the subtraction. Divided by 2 would be about, again, super approximate, -2.25, somewhere in that range. Okay, if I did the plus, -1 plus this, it's 2.5 over 2 would be approximately 1.25. Now, this is really, really rough approximation, and it's just to save us from having to do all this stuff on the calculator. I do want to confirm here, though. I'm going to graph both of these, and we'll check this out. So we'll go over to Desmos. And we had 2x squared. Can somebody read me the other part? Is it 2 even? X squared plus 2x minus 1. X squared plus 2x minus 1. And what was the other equation?
Y equals
X plus 2. Okay, now, we super estimated these. Are we pretty close with the guess of 1.25? Like, reasonably close that if we'd had a calculator, we'd be good. We said it happens at this x value and this x value right here. Was our other one pretty close to -2.3? Now, without a calculator, we can see that we're close. Unfortunately, here, we only have the x values. What if we wanted the y values also? We would have to plug it in. Now, in this situation, we get ugly numbers again. If you look back at the examples, just because I don't have them in front of me, on example A, were the solutions nice or ugly? Like in your notes, you'll have to look. A was ugly? Was
No.
It was a fraction and 0.
it this ugly?
No.
B was this ugly, right?
Yeah.
Okay, for this, If on the homework and stuff, remember there's way more ugly numbers than there are nice numbers, but your book tells me to teach you something that I'm not doing right now, and I'll not say any more about it than that. Your book will usually give you nice answers. Okay, should we do one more like this, or do you want to get a little glance? I'm not going to give you homework this weekend, sort of. We should probably talk about that. We have one more little section that we need, like not full section, but the only other part that we haven't done with this, we've used a quadratic formula, we've solved systems. There's only one more thing. I want you guys to do one more throwback problem for me that's not quadratic-y stuff. Okay, talk with each other. You guys get 5 minutes. And then I have something that I want you to start this weekend that we'll just agree we'll spend some amount of time on. It's not due for you guys on Monday, but I want you to get a start on it. Okay, so for this last one, and this is just a recall problem, so this is old stuff, I want you to solve, with whatever this means, the following. I want to know, when is it the case that y is less than or equal to 2x plus 1? There's one inequality. And we'll do one more. X plus y is less than or equal to 2. I want to know, what does a solution to this look like? Now, it's been a long while. This was like chapter 2.1 stuff, I believe. It's been a minute. First thing, is this a system of equations? Are these equations? It's a system of inequalities, which means we're not just looking for the point of intersection here. What are we looking for with these? And you're going to have to go back through your notes, I imagine, to find it. Somebody might have it already up here, but if you go back through your notes, how do we solve a system of inequalities? My guess is like 1.7-ish, 1.6, somewhere in there. I'm just going to let the awkward silence roll. So I'm waiting. I'm cool. Systems of inequalities. I bet there's some graphs and maybe a little shading.
Yeah, that's why.
Ooh.
Doing that.
We get to graph and shade. So here's, I see the faces in here, make me think that maybe you don't love that. We did ones like this. Now, for this one, we'll go through it really quickly. If I wanted to graph this line, how would I do it? And I'm going to sketch this. How would I sketch this line here? And I'll even do this one in red. Is it solid line or dashed line first? Solid, because, or equal to. Okay, now I'm going to do a really lazy graph, okay? What's the y-intercept of this top equation? 1. So check it out, here it is. And a slope of what?
2.
So if I know my y-intercept is 1, which I've just plotted here, how do I use a slope of 2 to get my next point? Up 2 and right 1. Okay, this right now is the line, roughly, 2x plus 1. Now, right now, as I look at the graph on the board, and I haven't put a scale or anything, right? We're just going quickly. How many regions did that red line cut my entire plane into? There's 2. There's an above region, everything up here, and a below region down here. Okay, if we wanted to test, can you pick any point not on this line? If I plug in 0, 0, and I tested, I would get 0 is less than or equal to 0 plus 1. Is that true? 0 is indeed less than 1, which means in my head, all of this is shaded right now. Okay, how would we graph this one?
Can you define it? Can you just move 0 to
Absolutely. If y is 0, what is x?
2?
2. And if x is 0, what is y? 2. So I know I get intercepts at 0, 2, and 2, 0. So it'd be like here, here's 2, and here's 2, and I can find a line through those. And right now, again, we said everything down here was true, so this region gets a red X, and this region gets a red X. What test point could we possibly use for that purple line? 0 plus 0 is less than 2, true or false? Which means everything down here from the purple line gets shaded. I put an X here and an X here. Is there a region that got hit twice?
Yeah.
It's right here. Now, we are going to be doing this on Monday. I'm going to give you one last parting gift before you roll out.